Thanks a lot, Mark. I appreciate it. Hopefully you all won't get too overly excited. I'm doing the intro talk. So it's going to be short and sweet, hopefully give you enough context to understand the following talks, which is where most of the interesting stuff is. I'm going to talk briefly about what Apache Beam is, why it exists. How many of you are familiar with Beam? Not bad. I'm going to then do a crash course on sort of kind of what you can do with Beam, just a very simple explanation of things. Like, how many of you are familiar with, say, Spark or Flink? Now we're talking. So for most of you that raise your hands, you'll be very bored with that. Sorry. But we wanted to at least make sure folks had a rough idea of the kinds of things we were talking about. Then I'm going to talk briefly about kind of the roadmap that we're looking at in the near term with Beam, specifically around Beam's portability layer. And then I'll talk about ways to get involved, both sort of as just a contributor out of the kindness of your heart, and also if you want to get paid to do this stuff. So why Apache Beam? I mean, I've got like 6 slides here to kind of send a simple message, but there's all sorts of reasons these days why we want to process data, right? Like, you've got data coming in, you're wanting to analyze user behavior, you're wanting to understand something about the world. And the more data you look at, the more the more data you have to handle, and you start doing this on lots of machines, and you start doing lots of different versions of this, and you're doing this all ad hoc, and then your life is suddenly hell. And all the sort of increasing devices in the world just make it harder and harder. So you're kind of building these ad hoc systems, and you end up realizing that you're really kind of building pipelines that do specific types of operations, and it'd be a lot nicer to use a framework that helps you out. So then you decide to go and find one, and you just sort of try to figure out which one to use, because there's dozens of these things, and they're just always changing and growing, and new ones are coming, and they're getting better and getting worse. And so the vision with Beam is that we really should try to find kind of the core model, the core foundations of what it is to do data processing. And you should be able to write what you want to do in data processing in whatever language you want. Like, you don't want to be a Java programmer that's going to show up and have to use C++. You don't want to be a Node.js programmer that's going to show up and have to use Java, et cetera, et cetera. And then, for the core of the stuff that you want to do, you probably should be able to run this on any engine that you want to run it on. The new engines are showing up with new capabilities. Some are more performant, some are less performant, but work in a better environment, in a different environment or something like that. It'd be really nice to not have to rewrite your pipelines, learn new frameworks, et cetera, be pigeonholed into a specific language, Java. So, the vision for Beam is that you can write your pipelines in whatever language you want, and then run them on whatever engine you want. And then these two worlds, kind of the world of SDKs that let you write pipelines, and the world of runners that kind of provide the engine capabilities, can kind of motivate and challenge each other, and really help push the other forward in the state of the art. So for those of you that didn't raise your hand when I asked you if you knew what Spark or Flink or other things were like, we're going to do a quick crash course to explain what exactly you can do with something like Beam. There's a few different types of operations in Beam. The core one is this thing called a pardo. That's just short for parallel do. And it's really similar to a flat map or map operation. It's basically kind of an element-wise transformation. So every element gets processed independently. You can imagine how this is easy to shard across lots of machines. This is things like filtering, converting dates, anything that's kind of element-wise. It can also be explosions, so prefix or postfix explosions. Another interesting type of operation they support are kind of aggregations. So these are things like per-key combines, reductions. And this is where you're grouping items by some key and combining them. When you're doing this in a streaming context, this is turning it into a stateful computation. And there's lots of different variations on this to give you kind of automatic optimizations under the hood for if you're doing like associative and commutative functions, et cetera, et cetera. But the main thing here is that you're taking in lots of elements, combining them together, and creating some new output. So maybe it's histograms, maybe you're computing sums, whatever. And then another thing that Beam brings to the table is this idea of event time windowing. So when I say event time windowing, how many of you know what I'm talking about? Okay, somewhere in between the number of people that know Beam and the number of people that know Spark. So when you're dealing with event data, events that happened in time. So some users on some mobile game, creating scores or doing something, and you're wanting to analyze those events within the context of where they occurred in time. You care about that time that event happened. That's the event time, right? But due to the nature of distributed systems, those events don't always show up at the pipelines at the time when they happen, right? It'd be great if an event happens and it gets processed immediately. Life would be very simple. But you got folks on mobile phones with sketchy connections, or maybe they're in airplane mode. You've got distributed systems that have hiccups or just arbitrary delays. Things can get reordered in the network, and so you can end up with things showing up at very weird times, and you need to sort of shuffle them back into place of where they actually occurred with an event time if you want to analyze them correctly in that context. So that's what event time windowing gives you. And the frameworks within Beam make it really easy to just specify, hey, I got these timestamps on my incoming data. I want to window it into some kind of windowing scheme, like fixed windows, slicing up time into even chunks, or you've got much more advanced, interesting things. But it basically gives you nice, clean, and simple ways to analyze events, as they happen in time, without too much cognitive overhead. Oh yeah, so you can tell I stole these slides because I forgot there was an animation. So there's, you can look in this stream of data, and those 3 events all happened at the same time, 8 o'clock. But you can see the, like the red one shows up relatively close to 8 o'clock, but that green one showed up very late. That's an example of sort of skew within event time. Another way to think about this is if you plot this on sort of a 2-dimensional graph. We have 2 dimensions of time here. So event time on the bottom is plotting, where in event time this actually happened. So this is the the times that the events themselves occurred. And processing time, the y-axis is showing us when those events actually show up at the pipeline and get processed. And you can think of, if you want to carve up event time into, say, fixed windows, those windows are all going to be basically vertical swaths through this, right? So like that orange kind of vertical bar area gives you, like, say, 1 hour of time, and then next to it is the following hour. And so any vertical distance in this graph is essentially capturing that kind of skew between when an event happened and when it was actually processed. So that's sort of the delay between when an event happened and when the system was able to see it. And if everything was right on that dashed line, that would be that perfect case that I talked about earlier of an event happens and it's processed immediately. But reality looks more like this, where you've got a lot of things that are maybe kind of close, but then there's these outliers, and the actual skew between them varies over time. You can't just assume it's some constant amount, and so life is difficult. So that's kind of the very short crash course in the kinds of things you can do with Beam, the kinds of things it tries to enable you to do very easily. We talked about the pardoos for per element processing, combine and group by key for aggregation, touched briefly on event time windowing. We've given a whole bunch of talks about this in much greater depth if you're curious. So if you just search the web or come grab me afterwards, I can point you towards more resources if you want to learn more. I want to talk briefly about the roadmap for Beam. A lot of it is focused on portability, and since I'm getting short on time and I don't want to take time from Robert, I'm going to skip over these. You can come to these slides. There's a link at the end if you want to see more details. But in short, our vision is this. Our vision is to have arbitrary languages on one side, arbitrary execution engines on the other. Reality about a year ago was more like this, where you could do Java on just about anything, and you could do Python and sort of Go on one thing. I'm happy to say that with thanks to the efforts of many of folks within the community, we're in a much better place here at the beginning of 2019, where we're finally getting this portability framework into place, where we've got a multitude of languages on the left side that are all now able to run on at least the ones that have been updated to the new portable runner framework. So Cloud Data Flow, Apache Flink, and SAMS is being bootstrapped now too. And over time, I believe more of these will move, and hopefully the list of languages will increase as well. So I'm going to wrap up here so that Robert can talk, but real quickly, I just want to say, if you want to get involved, come back to the slides and look at these links. We're on Twitter. We've got a YouTube channel if you want to learn more. We've got a Slack channel if you just want to dive in and ask some questions. We've got a user list and a dev list, is unsurprising for Apache. It's good ways to start, run some pipelines, on your favorite runner, report bugs, ask questions on Stack Overflow. If you really want to dive in and contribute, good resources for finding bugs or to report a fix. Try it out with Java 11. Try things out with Python 3. Write a Go pipeline. Try different I/O at large scale. All sorts of fun stuff like that. And we also have, I skipped past it, but we have a starter tasks page. So come to Beam. We've got a list of things if you want to kind of dive in and do some coding. If you want to get paid to do this stuff, we're hiring Seattle and Sunnyvale. Talk to those people. Those are the friendly recruiters that will make sure that they get routed to me once you go through. So we're hiring for the team that's focused on doing Beamwork. So if you want to do open source work at Google, please come join us. There's also openings for cloud data engineer professional services jobs, so you can kind of help folks that are working with Beam. But either way, we'd really love to have more folks helping out. So thank you all for listening to my short, quick intro talk. That's a link to my Twitter if you're curious, or my email if you have questions, link to the slides.